Okay students, today we are going to discuss Cauchy method of characteristics. So first question is what is characteristics of a PDE? So basically this is beyond our syllabus. So I am not going to discuss in detail what is the geometrical interpretation of characteristics and how we find the solution of any partial differential equation with the help of characteristics. This is out of scope. There is another method, very lengthy process. Here in this syllabus we will discuss only the method how to get the solution. So what is the standard equation which we are going to solve with the help of Cauchy method of characteristics? So let us suppose this is an equation a del u over del x plus b del u over del y is equal to f x comma y plus ku, where a, b and k, these are some constant or maybe the function of x, y on u, but not derivative of u. So you will not get any function del u over del something. So this is only the function of x comma y, u or some constant with this initial condition. So this is whole equation with this initial condition. We can solve this type of equation with the help of our Cauchy method of characteristics. So how we solve basically? So working rule, we are going to discuss working rule. So we find this equation. This is equation number 2. So the question arises how we get this equation. So if you studied total derivative, so total derivative is given by del u is equal to del u over del x dx plus del u over del y into dy. This is suppose equation number 1 dash. So if you solve this equation number 1 and 1 dash, you will conclude with this equation number 2. So I am just writing equation number 2, and very simple method. There is very simple method to write this equation. This is dx upon a, that is the coefficient of del u over del x, del y over b, that is the coefficient of del u over del y, is equal to du upon this whole quantity. So dx upon a is equal to dy upon b is equal to du upon f x comma y plus ku. And now we have discussed earlier the method of Lagrange's equation, solving Lagrange equation. With the help of this method, we will try to find the solution of this equation. So first we take first two term, del x upon a is equal to del y upon b. From here we get bx minus ay is equal to c. Okay. Now taking first and last fraction. No, this is not always first and last. This is very important point which you will have to notice. That means first we take these two fraction and get one solution. As Lagrange's method we have discussed, we find two independent solutions taking two different fractions. So here we take first two fractions to get one solution, and for another solution we can take any of the two fractions, first and third, second and third, whatever is easy for us, or whatever boundary condition are given to us according to that. So here I am just considering that is first and third. So dx upon a is equal to du upon this much, that is dx upon a is equal to, now we are using rule number 2 of solving Lagrange's equation. So that means we will replace this y with the help of this first solution. So this is the first solution, and in this first solution we get y is equal to bx minus c divided by a. So we put this value here. So we get dx upon a is equal to du upon fx bx minus c upon a plus ku, and we integrate this factor, and finally we get this type of solution, u is equal to g x comma c plus c1, some constant, integration constant. But this is the main point here which we have to remember. This c1 here, which we are taking the constant of integration, is not arbitrary c1. Here we consider this c1 is nothing but the function of this c. What c? Which we got in our first integration, that is taking first two part. This is the only method which we will, this is the only point which we have to remember. So once we solve second integration, we will not choose any arbitrary constant of integration. We take this arbitrary constant as a function of some constant which we have got earlier. So here this quantity is c. So this c1 is nothing but the function of some c. So our solution is u is equal to gc plus some function of c, and we will determine this function gc with the help of our boundary condition which is given here, u 0 comma y is equal to zy. So we will put the value of x is equal to 0, or it may be y is equal to 0, whatever given is there, and we solve this equation to get the value of GC, and after getting the value of GC we put this value here in this equation and get the solution. I hope you could understand. Now I am taking an example. It says that equation del u over del x plus del u over del y is equal to x plus y with the condition u x comma y is equal to 0. Here I have said earlier, it could be sometimes u 0 comma y is equal to some condition, or u x comma 0 is equal to some condition. So here in this question it says when y is equal to 0, this u is 0. Find the solution. So first of all we will compare this equation with our standard form, and this is our standard form. A del u over del x plus b del u over del y is equal to f x comma y plus ku. From here we get a is equal to 1, b is equal to 1, f x comma y is equal to x plus y. And then our equation, as I have said earlier, we get equation like dx upon a is equal to dy upon b is equal to du upon fx plus y plus ku. So here we get dx upon 1 is equal to dy upon 1 is equal to du upon x plus y. So now we will solve this equation taking first two fraction. So once we take first two fraction we get dx upon 1 is equal to dy upon 1. So here we get x minus y is equal to c. This is first solution. Now another point which is to be remembered here, in this condition which is given to us, initial condition y is equal to 0, that means we are trying to impose our initial condition on y, that when y is equal to 0 solution is 0, x is whatever could be. So here in this question we will take the fraction which containing y, that means we will take second and third fraction rather than first and third. If it is something like x 0 comma y is equal to something 0, so in this case the condition is apply on x, so we will take first any x and u fraction. So here since the condition is on y, that when y is 0 u is 0, so in this solution y is dominating, or we can say y is deciding the solution, so we will take solution at the second fraction and third fraction. So here we are taking second and third fraction, dy upon 1 is equal to du upon x plus y. So this is of y, this is of u. What about this x? We have to remove this x. How we will remove? We will use equation number 4. So from equation number 4, x is equal to c plus y. So we put c plus y here. So we get dy is equal to 1 is equal to du upon 2y plus c. Next, variable separable, 2y plus c dy is equal to du. Integrate this, so we get u, basically this is u x plus y. Here everywhere u is function of two variables. So u x plus y is equal to y square, the integration of 2y is y square, integration of c is cy plus some constant c1. But as I said earlier, in Cauchy method of characteristics, we don't take c1, that is arbitrary constant, we take some function of c. So rather than we are writing c1, we will write it gc1. So you have to remember it. So our solution will become u x comma y is equal to y square plus x minus y into y plus g x minus y. Basically we put the value of c. Since c is equal to x equal to c plus y, c is equal to x minus y. So we put it here. So we got this value. Now our next objective is to find the value of this function g. What is the value of g? So we put y is equal to 0 in equation number 5. So we get u x comma 0. This value is given 0. This is initial condition. We put y is equal to 0, this value becomes 0 plus g x comma 0. So which implies gx is equal to 0. What does it mean? It means x minus y is equal to 0. So what do you mean by this? Basically it says that whatever argument this function g has, the value is always 0. We are not considering what is the value of this. We are considering any argument. Since x is arbitrary, gx is equal to 0 implies whatever value this function have as an argument, the output will be 0. So which implies gx minus y is equal to 0. So we will put gx minus y is equal to 0 in equation number 5. We will get the solution u x comma y is equal to xy, and this is the solution. And you can verify it also. If you find del u over del x, you will get y. If you get del u over del y, you will get x. If you add these two, del u over del x plus del u over del y, you will get x plus y. This is the differential equation which we are solving. So this is the correct solution.